Hello everyone. So this is a little video about how to write chemical formulas. So first I'm going to review with you some things to consider. First of all, the positive and negative charge must be equal. Sometimes charges are called oxidation numbers or oxidation states. And the sum of the charges, if you add them together, the sum must equal 0. So positive and negative got to be equal. That would make them add up to equal 0 if the positive charge equals the negative charge. Thirdly, charge can vary. If charge varies for some elements, then Roman numerals can be used. So if we go to a periodic table, for example, if you look at, say, iron here, see how it's got a +3 and a +2, or cobalt will be a 2 or a 3, or nickel will be a 2 or a 3, or copper a 2 or a 1, and so on. So these are variable charge elements, and if I'm asking you to write a formula for a compound that contains one of these elements, then you'll have to be told what the oxidation number is, or which one to use. So that's what this means. If there's more than one charge, Roman numerals will be used. And then sometimes groups of atoms act like one atom. So those are called polyatomic ions, and they're down here at the bottom of the periodic table that we've been using. So you can see these polyatomic ions, like sulfate is SO4 with a -2 overall charge or oxidation state. So that means that this whole thing together has a -2 charge. And this whole SO3 together would have a -2 charge. It has there are different names. There's sulfate and sulfite. All right, and then the last thing I was going to mention, number 5, if the name ends in IDE, that means you're looking at a plain element at the end. So for example, up here it says nitride, that means nitrogen. Phosphide, that would mean phosphorus. If the name ends in ATE or ITE, then we're talking about a polyatomic ion at the end. There are a couple of exceptions, so I might remind you about the exceptions. So note hydroxide and cyanide and peroxide end in IDE, but they're binary they're polyatomic ions. So things that end in IDE are usually what we call binary compounds with just 2 elements or a plain element at the end. However, there are 3 polyatomic ions that end in IDE. One of them is hydroxide. It has a chemical symbol OH, has a -1 overall charge. Another one is cyanide, has an overall -1 charge, and another one is peroxide, and it has a -2 charge. All right, so as a little review, we can see if we can apply to some examples that I've preloaded here. So we'll look at potassium chloride first. I just put some examples up. We got K would be potassium. The symbol for chloride would be Cl. We know it's just plain Cl because it ends in IDE. All right, so you go overlook your periodic table. I'm going to go back and forth right now. I won't always review them. I'll just remind you what the charges are. You should have one of these in front of you as you're watching this video. So potassium you'll see is +1. Chloride's over here, and it's -1. Right there. Right there. -1. All right, so we'll come back and write the formula. So if K is +1 and Cl is -1, then that first rule has been met. The positive and negative charge must be equal, and the sum must equal 0. So that one does it already, so we're finished with that one. +1 and -1 are equal and opposite, so we're finished. The second one has potassium. Again, it's +1, But this time it's sulfur at the end. If you look at your chart, it's -2. So if that's a +1 and that's a -2, I'm going to need to have 2 atoms of potassium to match that charge. So you put a 2 after the K. So now we have 2 plus 1s, which is +2. So 2 times 1 is 2. That matches that -2, so we're finished. Over here we got lithium phosphide. You got Li. That's +3. Excuse me, +1. And phosphide's -3. And you find those on your chart. So we take a quick look at it. There's phosphorus at -3. And here's lithium up here at +1. Right there. Alright. So if we have a +1, let's erase this whole thing just for a second. I got a little mouse issue. Alright, so let's start it again. Lithium is +1. Phosphorus is -3. So how many positive 1s do I need to match a -3? Well, you're going to need 3 of them. So you need 3 atoms of lithium to match that -3 charge for phosphorus. All right, now when we get the formulas written, it's important to know that these charges are really not part of the formula. You have to think about them, but they're not a required part of the chemical formula. All right, now I'm going to go a little faster down here. The barium is +2. You'll find that on your chart. Iodine is -1. This time I'm going to have to manage the number of atoms of iodine, not the barium, because the barium's got a +2. If I put 2 I's here, that would match our +2 charge. So 2 negatives matches a +2. Over here we got magnesium oxide. Magnesium is +2. Oxygen is -2. So they're already even. So we're finished with that one. Over here we got beryllium and nitride. Nitride means nitrogen. Remember, the IDE ending means that you have just a plain element. So oxide is oxygen, iodide's iodine, fluoride's fluorine, and so on. Okay, so if you look at the periodic table, beryllium will be a +2. Let me show you that real quick. Beryllium's right here, +2. If you go to nitrogen, it's -3. Well, 2 and 3 are not equal, and I can't multiply 2 by something to get it equal to 3, nor can I multiply 3 by something to get it equal to. So I have to look for a number that is divisible by both of these numbers. We call that a least common multiple. And the number that is divisible by both 2 and 3, the smallest one, is 6. So how many atoms of beryllium would you need to make a +6 charge? Well, 2 times something equals 6, so the something is a 3. So you're going to put a 3 down here. Then the nitrogen has a -3 charge, so you need to multiply it by something to get 6. What would you multiply by? So you multiply by 2. So Be3N2 would be your final charge. This is a little bit of a sloppy looking N here, so let's fix that. Maybe. Okay, there we go. All right, over here we got aluminum fluoride. So aluminum, Al, fluoride, F. The charge on aluminum is +3 if you look at your chart. Fluorine's -1. So how many -1s do you need to match a 3? Now we hit our first one with a Roman numeral. The Roman numeral tells you the charge. So we got iron. If you remember iron, as I showed you earlier, iron has a couple of different possible charges. So right here, 3 and 2. So we could have iron 3 something or iron 2 something, but this we're told to use iron 3. So since it has a 3 in the parentheses, that means the charge that we are going to use is the +3. And then sulfur, if you look at your chart, will be -2. So now we're in that common multiple situation again. See how we had 2 and 3 up here where you couldn't multiply 3 by something up here to get 6, and you can't multiply 2 by something. Let me say that again. You can't multiply 3 by anything to get 2, so we had to find a common multiple, which was 6. So iron, we got a 3 and a 2. I need to multiply the 3 by something to get 6, and I'm going to multiply the 2 by something to get 6. So what will I multiply the 3 by to get 6? That would be 2. What would I multiply 2 by to get 6? So 2 times 3 equals 6. And there's our formula. See, our total negative charge would be -6. 3 times -2. And our total positive charge would be +6. 2 times +3. Our next one's nickel 3 nitride. So nickel and nitride. Nickel's +3. Nitrogen is -3. So they're even already. We don't have to do anything else. There's nothing else is required. And again, remember, we don't really need these charges after we're finished. I won't take off, I wouldn't take away credit if you put the charges up there, but I want you to know that they're not necessary, other than you have to think about them as you write the formula. Okay, I put 3 down here with, that sometimes confuse students. For the last 3 examples of this particular kind of compound, we've got lead, we've got oxygen. So this IV is a Roman numeral for 4, and oxygen's -2. So how many times does 2 go into 4? I can multiply the 2 by 2, and that would give me 4. So 2 negative 2's match the +4. Remember, the sum of the charges has to equal 0, and the positive and negative must be equal, the total positive and total negative. All right, so now lead 4 nitride. If I did that one, this is a little bit more complicated, but not, I mean, it's just a bigger number. So this is +4, nitrogen's -3. So what's the lowest number that's divisible by both 4 and 3? So it'd be 12. So what would I multiply 4 by to get it to equal 12? So I'm going to multiply the 4 by 3. And what would I multiply the 3 by to get 12? And there's your formula for lead 4 nitride. Bismuth. Now bismuth is in the -3 column, but as you go down the periodic table, remember the size got bigger because you're adding energy levels. And what happens in that particular column is that when you get down here with the bigger atoms, they actually change to metals, and instead of gaining, they tend to lose electrons. All right, so bismuth is +5, and phosphorus is -3. So now what's the least common multiple of 5 and 3? So I would multiply the 5 by something and the 3 by something to get so they both equal the same number after they're multiplied, and the lowest one is 15. So 5 times 3 would equal 15. And then if I multiply the 3 by something, I would need to multiply it by 5 to get it to equal 15. So our final formula will just be Bi3P5. All right, so now I've given you examples of all these ides. I haven't done anything with the 8s or ites. So I'm going to do a couple of those to show you how they work. I'm going to just squeeze them in between these 2 lines here. Whoops, I'm in the wrong places there. So I'm going to put a line here. I'm going to put a line here. And we'll do 3 or 4 examples. Okay, the first one I'll do would be, let's do calcium nitrate. Okay, notice the ATE ending. ATE ending means, the ATE ending means that it is a polyatomic ion. Now it's in your rules down here. Remember, the name ends in ate or ite. It's a polyatomic ion. So we'd write down a symbol for calcium, and then we go to the periodic table. That's on the bottom of your table. There's a list of polyatomic ions, and look for one that says nitrate. Oh, there it is right there. See right here? Nitrate, NO3. And it has a -1 charge. Oops. There we go. So calcium and then nitrate's NO3, and its overall charge was -1. Off of your periodic table, the calcium's +2. So how many -1s do I need to match a 2? Well, we did one like that, I think, up here. Right here, we have a 2, we have a -1. So how many of these did it take? You needed 2 of those iodines. So you need 2 of these. But since this is a polyatomic ion, you need to put parentheses around the ion to show that you need 2 of the whole group. So this is a group of atoms with one identity. So you need 2 of the whole group to make the formula correct. Let's take a look at another one. Suppose we had aluminum sulfate. And again, it ends in ATE, so that touches the polyatomic ion. So you have aluminum, and aluminum has a +3 charge off your periodic table. Then if you go and look at your polyatomic ion list and find sulfate, you'll see it right here, it's SO4 with a -2 charge. So we're going to write in SO4, and it's going to have a -2 charge. So now we need a least common multiple of 3 and 2, which we've already said is 6. So you're going to put a 2 here. 2 times 3 makes 6, and you put a 3 down here because 2 times 3 equals 6. Remember though, since this 3 needs to apply to the whole group, remember this is a group of atoms with one overall charge, you put the group in parentheses. So put this group of atoms in parentheses, and that's our final formula for aluminum sulfate. And again, the charge doesn't need to be there after you've written the formula. So it's just Al2SO4 3. So polyatomic ions work the same way that these guys do, the plain elements, except that you put them in parentheses. Let's take a look at a couple more. All right, so here's one aluminum. I'm just making these up, of course, although these compounds do exist. So aluminum hydroxide. Okay, so you know it's aluminum. And then you see the IDE ending and you think, oh, it's a plain element. But remember, there are 3 polyatomic ions that end in IDE, and one of those is hydroxide. So it's OH with a -1 charge. So what we would do is write down OH. It has a -1 overall. Aluminum is +3. All right, so now I need to multiply 1 by something to get 3. This is a common mistake that students make. If you have more than one of any polyatomic ion, you have to have parentheses. So you're going to put the OH in parentheses and put the 3 outside. So more than one of any polyatomic ion requires parentheses. So aluminum hydroxide would be your formula. AlOH3 would be your formula, but the 3 has to follow the OH in parentheses, because you need 3 of the H and 3 of the O, since they together have an identity. All right, last one. Let's suppose we had sodium phosphate. All right, so sodium is Na, and it has a +1. Phosphate is PO4, and it has a -3. Right. So there are 3 sodiums, because 3 times 1 is 3, and that matches this -3. In this case, you do not have to put the parentheses around the PO4, although for right now, it might help you to do that, just to keep in mind that it's a group identity. But we're going to put a 3. Whoops, mix that out. 3. This was a -3. All right, so we got a 3 here and a -3, so it's Na3PO4. So let's take a quick look there one more time. All right, so Na3PO4. All right, there we go. And that is the end of this little video. Remember, you do not need the parentheses here because there's only one of the polyatomic ion phosphate. All right, so I hope that helps, and we'll stop it there.